Imagine a simple-to-remember open code that pinpoints a specific area of just a few square meters, such as the entrance to a house or any other location. Since the latitude and longitude coordinate system can be quite complex, we can transform the two coordinates into a single number, reducing it to 9 to 11 characters, used as a scientific code for application in the census and data analysis. Geohash and open location code are examples. But it's still difficult for a human to remember these codes. For logistical use, we need a shorter code. To shorten the code, we can take advantage of the geographical context. For example, if the target point is in the city of São Paulo, in the state of São Paulo, in Brazil, if we replace the beginning of the code with BR for Brazil, SP for the state of São Paulo, SPA for the city of São Paulo, we can greatly reduce the difficulty of remembering the city's codes, since they will all start with this prefix and end with a 5-character suffix that will be easier to remember. This is what we have done by developing the AFA.codes methodology. The AFA.codes methodology recommends that the approach to shortening the code should be customized for each country. In fact, the method of code shortening explained for Brazil may not work well in other countries with different territorial organizations. For example, in Colombia, our government agency contacts chose to use the administrative number used for the census, called DVIPLA, as the AFA.codes prefix, rather than a system of abbreviations like Brazil. In other countries, where the postal code is widely used by the population, such as France, it is more appropriate to use the city's postal code as the code prefix. Therefore, the first advantage of the AFA.codes methodology is its adaptability to customize the code shortening process for each country. The second advantage of the AFA.codes technology is that it uses base 32, which is very efficient to compress the code. For example, the number 22 in base 10 and in base 20 has 2 characters, and the same number in base 2 has 5 characters. But in base 32, the number 22 has only 1 character. Creating a geocode involves selecting a grid to systematically divide the area into cells of the desired size. For instance, Zone A can be divided into 4 cells, each further subdivided into 4 cells, and so on until reaching the target cell size. There are a number of global grid and projection technologies in the DGGS standard, discrete global grid systems, but none is being used by any of the agencies responsible for the census. For the census, a grid adapted to each country is needed. The third major advantage of the AFA.codes methodology is that it uses the projection selected by that country's statistics office for the census grid. In Brazil, for example, the IBGE selected the Albers projection to ensure uniform cell size across a vast, non-distorted territory. The fourth advantage of the AFA.codes methodology is that it offers hierarchical codes, meaning the name of a child's cell contains the name of the parent cell, a valuable feature in numerous scenarios. The fifth advantage of the AFA.codes methodology is its multifinality. The grids used for the geocodes, which we call logistical, point to cells ranging from 1 meter to 6 kilometers on a side, in 6 levels. These codes interact with scientific grids that allow the territory to be cut into cells ranging from 1 meter to 1048 kilometers on 41 levels, depending on the need. Consider this logistical AFA.codes, BRSP, SPA, JPVH2. It shows a 6 meters area in São Paulo. The set of logistical grids allows us to have 6 different grid levels with 6 different cell sizes. Note that this same cell also has a scientific AFA.codes with characters that are harder to remember, but this is not a problem because it will be used by a specialist, a data analyst. Notice how many levels of scientific grids we have with different cell sizes. This number of cell size options proves advantageous for data analysis and cross-referencing. We strongly believe that choosing the right geocode system is crucial for a country. Therefore, adapting it to each country, while respecting its sovereignty, is not only important but also a way to improve efficiency and gain acceptance from the people. Let's highlight the 6 advantages of the AFA.codes methodology. 1. The way the code is shortened is adapted to the culture of each country. 2. It uses base 32, very efficient way to compress the code. 3. It uses a projection appropriate to the country. 4. It uses a hierarchical code. 5. It allows interoperability with scientific codes, which guarantees the multifinality of the project. 6. AFA.codes is an open technology, free for all. Contact the AddressForAll Institute, and we'll be happy to help your country choose the best open geocode with the AFA.codes methodology. Thank you.